Good day, everyone. Welcome back to another of our class. And today we'll be talking on the differentiation of exponential function and logarithmic functions. We want to know how to differentiate natural exponential functions, general exponential functions, natural logarithm functions, and general logarithmic functions. Please stay tuned and let's go straight to the note and see what we have for today. Thank you and God bless you. All right, so the differentiation of exponential and logarithmic function. Now let's look at the exponential function. So differentiation of exponential function. An exponential function is one in which the variables appear in the exponent. That is the variable that we are differentiating appears in the power. The exponent is known as power also, right? So natural exponent, when you have your epsilon number e raised to the variable x, to get the derivative of ex, we use the chain rule, which is we initialize u as x, and now we have y equals to eu, and now our chain rule is the dy dx is equals to dy du times du dx. So dy du, now when we differentiate dy du, differentiating eu, it's still eu because we differentiate only the epsilon number, and epsilon number is a constant, right? Is a mathematical constant, right? So you both EU. Now we have du dx. Now u is equal to x. So when we differentiate x, we have 1 times x raised to power 1 minus 1. And 1 minus 1 is 0. So you have 1 times x raised to power 0. And nt raised to power 0 is 1. So we have 1 times 1. So we have 1. Now du dx is equal to 1. So e raised to power u times 1 is equals to e raised to power u. And u is equal to x. So we have e raised to power x as our answer. So the derivative of e raised to power x is still e raised to power x. Now let's look at this other example. E raised to power 2, y is equal to e raised to power 2x. Now let's initialize u equal to 2x. Now we have e equal to 2x. So derivative of e equal to e raised to power 2x is equal to e raised to power u, because we now say let u be 2x. Now dy du dx, because if we differentiate eu, we will still get eu. So let's differentiate du dx. When we differentiate it using our power rule of differentiation, I taught you that it's 2. Differentiate 2x is 2, right? And we have eu multiplied by 2, it's equal to 2e raised to power u. So now u is equal to 2x. So we have 2e raised to power 2x as your final answer. So that's the derivative of it. Now let's also look at exponential function with base. So the base can be a, that's why we're writing a here with the base. So we have y is equal to ax. Now derivative of a, it's now you write the function to get the derivative of a raised to power x. You write the function. Now this is not natural exponential function. This is general exponential function. Please note this. So we have the variable. So if the difference between the general exponential function and the natural exponential function is that the general has any base, but for the natural, the base is e, the epsilon number, right? So we have a raised to power x. To find the derivative of a raised to power x, you now say you write the function a raised to power x, then you get the natural log of the base, which is natural log of a in a. Then you look for du dx, which is the exponent. So yeah, this is an example. Y is equals to 5 raised to power 2x plus 1. Now you see we initialize u, we say let u be equals to 2x plus 1, right? So now du dx now will now be what? 2. When you differentiate 2x, you have 2. When you differentiate 1, which is a constant, it gives you 0. So 2 plus 0 is 2. Now dy dx of this function using the formula that we are giving there. We will now write the function 5 raised to power 2x plus 1, then multiply by the natural log of the base, which is the base is 5 here, so in 5, then du dx, which is du dx is 2, which is 2. So we have 2. Now your final answer is 2 natural log 5, 2 multiplied by natural log 5 multiplied by 5 raised to power 2x plus 1 as your final answer. Now, differentiation of logarithmic functions. Now, this is logarithmic functions. Please note the difference. Note the difference. Now, we have natural log. Now, let's do for natural log. Now, where we have y equals to natural log x, which is in x. So, derivative of this is equal to 1 over x multiplied by du dx. Now the du dx is the x there, you will initialize u to it using your chain rule again. So when you now put your u, it will now be what? In u equal to derivative of in u is now 1 over u. Now du dx, when you differentiate x, you have what? 1, because x is equal to 1 times 1 times x raised to power 1 minus 1, and 1 minus 1 is 0, so we have 1 times x raised to power 0, and nt raised to power 0 is 1, so we have 1 times 1, which is equal to 1. So 1 over u times 1 is equal to 1 over u, but u is now equal to x, so we have 1 over x. So the derivative of derivative of in x is 1 over x. Now this is another example. Y equal to in x squared plus 1. Now we say let u be equals to what? X squared plus 1. So y is equals to in u. The derivative of in u is equal to 1 over u. Now du dx is x squared plus 1. So differentiate x squared plus 1. We have what? When you multiply 2 by x and reduce it by 1, we reduce the power by 1. 2 minus 1 is 1. So anything raised to power 1 is that thing. So we have 2x plus 0, which is equals to 2x. So dy dx will now be 1 over u times du dx. So we have 1 over u times 2x. So when you multiply, you have 2x over u, but u now is equal to x squared plus 1. And now we have 2x all over x squared plus 1 as our final answer. Logarithm with base. Now this is a logarithm with base, our normal general logarithm that we all know. Y equals to log x base a. Now derivative of log x base a is equal to 1 all over x natural log a multiplied by du dx. Now let's say u is equal to x again. U is equal to x again, so we have 1 over u in a multiplied by 1. So we have du dx is equal to 1, right? So we have 1 over u in a, which is 1 over x in a. Example, y is equals to 3x plus 1 base 2. Now let u be equals to 3x plus 1. Now we have log u base 2. We have 1 over u natural log 2 multiplied by du over dx. Now du dx is when you differentiate 3x plus 1, you have 3 plus 0 equals to 3. Now we have 1 over u in 2, 1 over u natural log 2 multiplied by 3. So now when you multiply, you have 3 all over u in 2. Now, but u now is equals to 3x plus 1. So we have 3 all over 3x plus 1 in 2. So that's your final answer. So that's how to solve problems when you talk of natural, exponential, general exponential functions, natural logarithms, and general logarithms. Thank you and God bless you. Please ask your question in any area you have a question. Thank you.
Quiz.